Thank you, Eunice. And thank you all for coming back. I'm going to have a short section here to wrap up my piece. Just talking about validation and testing and how all of our design and theory comes together in developing the product, testing, validating, and ensuring it performs correctly and complies with relative standards. And then I'll be passing over shortly to colleague Robert Breeden. Robert is going to talk about generator ratings, some electrical aspect and some control system. And then that will lead us into lunchtime. So with our FG Wilson product, it is not a matter of taking an engine and an alternator, bolting them together and seeing what happens. Everything is designed, modeled through our new product integration process, our NPI. We have, if there is a new development in the engine, where say the engine has a new release, once our Perkins engine is finalized in its design and it becomes a released engine, we work with Perkins to develop the cooling group selections. That cooling group selection occurs at FG Wilson, and then through our combined test facilities, we will test and validate that system. Now, that comes from the total package integration design and then the testing associated with it to make sure that product is released with performance, reliability, and all of the support mechanisms that go into the product support for aftermarket support, from drawings to data to torsional vibration analysis for damper selections on engines. All of this comes through in the design process. So what we have is that we're looking at compliance to meet requirements for ambient, for its rating, for noise performance, specific local regulations, how the fuel system with the tanks are designed in the package to give our required minimum capacity or our extended capacities. This all falls into package design. This process does not happen as soon as the engine is developed. Our MPI process tends to be, on average, for a new engine, that will be between 12 months to 2 years, that all of this design process and integration and validation, how that occurs. What we do is that it's designed to meet all of the relevant standards and performance and regulatory requirements that come along with local legislation for every particular area. So we are a Northern Irish company, historically, but we've supplied since 1960s, we've supplied to a global market. The majority of our generators do not stay within our local region. UK is a big market for us, Europe's a big market, but we are mainly a manufacturer and exporter of generators to every market globally. So what this, one video, excuse me. Yes, so this is our Larne facility. I mentioned the engineering, this is our production facility, the large area. We have our engineering center of excellence, spent $26 million, Caterpillar's money, on producing our engineering center of excellence. This is $6 million acoustic facility. We have then our reverb rooms. We have our testing for noise. We test for cooling capability. We do vibration testing. All of this, the hemianechoic chamber and noise is one of a number of functions of test. It's the most impressive looking one because it's not what you normally see in the generator industry. But we test everything down to fuel consumption, emissions. We're looking at heat through our connections and on our cabling connections, management of that heat through the insulation. We have water ingress tests. When I was a 20-year-old kid testing generators, water ingress test was a big bucket with holes in it. It's not like that now, so it's very automated. These are our vibration tables. We do seismic testing. All of this leads into the development of the product, but we don't finish there. Every generator is then tested to a specific set of test requirements through our test cells. These are the test cells that Robert and I would have worked in, the bespoke larger test cells in Larne, so Bay F. These are for factory witness tests or for testing very bespoke generator applications. What this does is develops a test method for us to employ everywhere globally that we manufacture generators. So when the tests that we carry out at the bottom of Bay D in Larne is the same tests that we have in our China facility. And this all feeds back into the quality of the product, but also our manuals, our components. We used to be able to build an engine and change something off the line. That doesn't happen anymore. It must be through a SAP system, so that updates the manual automatically. The drawings are updated. All of it is there for aftermarket support. So this means that we're certified, independently certified against our regulatory requirements and legislation. And it's not a matter of certification of engine and panel and alternator. It's the combined generator certification. So we sell a generator package. We manufacture a generator package, and that's our warranty. Our testing is for the total package working together, working in uniform. This NPI, I do remember one NPI being under 12 months, but generally it is around the 2 years. Some larger product with a lot of remote system integration can move 2 to 3 years. That is because of the degree of engineering and testing we put into each product and product development. All of this test data, all of this engineering support, all of the solutions engineers in Larne, what this does, it allows us not just to design the generator to sit outside a building. We do the full system integration of how it performs in the building, how it interacts with the building. Fire systems, acoustically, control systems. We have sites where we control 700 breakers through buildings. Main simple function of all of this testing is that we get to actually design the room, and we do room design, conceptual room design and detailed room design for the applications. So we have our plant room installation and selection. This is an example we've done this was a site where we were doing 2,000 kVA generators. It was a high ambient application, 11,000 volt alternators, high ambient cooling groups. There were 5, so it was 10 MVA, 11 kV. We had hot standby PLC, multiple switchgear, neutral earthing resistors, also specific factory acceptance test for that client, long road runs. And then we had acoustic treatment, there was sand trap separation. There was an integrated fuel system, quite complex, but it also had to have fire suppression, in this case water mist, fire suppression. And then it was all a full design package for commissioning for an integrated system test. So at the end, the IST was integrating all of the system and that part of the building. From my perspective, it starts off with noise. So how big is the room? How big are our attenuators? We're looking at our noise calculation. We're taking our noise data. We're adding the noise sources. Then we're distance losses to specific receptors. What this gives us then is a noise level at 1 meter per generator to meet the overall requirement. Then we look at the space itself, and we look at the reverberant coefficient. So basically what happens is, if we know the noise source is here, we look at a room like this and we can calculate what noise level you will hear in the back row, what noise level you will hear in this, and which octave bands. Our calculations are pretty accurate. Quite detailed, but it gives us a lot of confidence in what we build, and we know how it performs. These are our calculations then for our size of our attenuator, our acoustic treatment. We take our noise sources. This is one that I'd carried out for this project, and we use the different forms of attenuation and different specific attenuator sizes to get the overall requirement. With that, we look at the pressure drop. So we look at how much restriction we have to ensure our cooling is maintained and that we can size our cooling group. So we'll have an overall pressure capability, and we calculate how much pressure we're using up with our attenuation and our system. We look at our exhaust sizing, specific sizing of exhaust for noise level and for distance and position. Theoretically, there is no limit on distance. Commercially, there is a very big effect on long flue runs, but we can design, size that, select it. We do the pressure sizing. We also do recommendation on drainage for condensation drains and drainage points, and then containment of those. What this then results in is we generate a design for that application. So this was taking air in, turning down. We had sand traps through attenuators, water mist fire suppression, attenuated on the outside, discharging vertically, and we had this exhaust to discharge over the outlet. Sorry? It's effectively a louver. It creates like a cyclonic effect. So the particle goes one direction and strikes a metal plate and drops down, and the air turns and back in. We buy them mostly. We normally buy them in. There are different types. The higher the performance, the more restriction. We do a few of these. Yeah, decent few of them. Slightly different manufacturers for different applications. And this was slightly difficult because this section view, there's lots of space. That was up here. You come down, not so much space. It was a curved building. It was a stadium. And we look at each aspect of it and each selection to create the overall design. So that is my section finished. So thank you very much for your time.